Hello, my name is Rachel Fuller and I am one of the Year 5 teachers at Wonersh and Shamley Green, and I'm going to talk to you tonight about maths in reception and in Key Stage 1, so Year 1 and 2. The two main aims we have this evening are to explain how we teach maths in those year groups using the mastery approach, and to give you some ideas for how you can help and support your child at home with maths. So what is a mastery approach? We've been using it for the last 4 and a bit years now at our school, and the main differences are that we have high expectations for every child, so whatever their ability, we're trying to keep them all doing the same maths. And we very much use mathematical representations to expose the underlying structure of the maths, so we're going to look at that in a bit more detail, and that really helps the children make sense of the concepts and enables them to become fluent. And then alongside that fluency, we are using problem solving and reasoning constantly to try and deepen their understanding of all the different concepts. So challenge is provided through an increase in depth rather than moving on to the next year group's objectives. So that depth is created from the problems. So this is a quote from the Director of Maths Mastery. In maths, you know you've mastered something when you can apply it to a totally new problem in an unfamiliar situation. So that's what we're aiming for. So there's an emphasis on moving from concrete to pictorial to abstract. And certainly when I was at school, we used to use Unifix cubes and maybe even Cuisenaire rods and things, and then we went from that straight to the numbers. And now what we're doing is we're putting this part in the middle, which is the pictorial step. So we'll have a look at that. So the concrete resources, sometimes we call them the manipulatives, they are all the things that your children use in class to help them understand their maths. So starting in reception, they have loads of different things. They might have dinosaurs, they might have jewels, they might have little compare bears, they've got cubes, they might be using counters on 5 frames or 10 frames, and the Numicon. And then moving into year 1, we'd carry on using Numicon and bead strings and 10 frames, and the multi-link and the Cuisenaire and the base 10, otherwise known as Dean's, is perhaps more for year 2. And then once they have really explored the concrete, we give them these pictorial models that really help them expose the maths. So starting in reception with part-whole models, and they might be using the top half of a tens frame called a 5 frame. Year 1, very much about the tens frames and using number lines. They'll be introduced to the bar model, and then year 2 will be looking at the 100 square and very much drawing their own base 10 and looking at how base 10 can be represented as a picture. So in reception, we provide the children with opportunities to practice and improve their skills in counting numbers, calculating simple addition and subtraction problems, and then interwoven into the curriculum is lots on shape and space and measures. And obviously much of their learning is practical, and it might happen in many different contexts in the classroom and of course outside. So there are 4 main skills that children need to develop before they can count, before they're fluent. And we start off, and this is, some of these skills will be preschool for some of our children. They will be needing to learn the sounds of the numbers. So counting 1, 2, 3, 4, 5, and they go 1, 2, 3, 4, 5, 9, 10, 11, 13, 16. And they start that at a very young age, and they're learning those numbers through songs and through rhymes and through reciting numbers. And then the next step is understanding that one-to-one correspondence and being able to match one object to another person or to another object. So my favourite for this is counting steps, because when you're counting steps, you're putting your foot on the step, and as you count, you're touching something. So it's 1, 2, 3, 4. So that is one-to-one correspondence. Children need to understand then what is meant by how many are there. So they are then counting by touching the objects, and they learn quite quickly that if they have them in a line, or if they move them into the line as they're counting, or they move them from one side to another, that really helps them be accurate. And then lastly, they need to know that the number of objects is the same, however they're arranged. So whether they're in a line, or whether they're jumbled up, we still got 8. So moving on, this is about subitizing, which basically means recognizing a number. So we don't need to count those 6 spots. We know that's a double 6 because over the years we've learned that's a double 6, and the children in reception are beginning to pick that up. So with the Mnemocon, they will quickly begin to recognize that that is a 3 and that the 3 looks like a backwards L. Well, they won't think that, but they'll begin to start recognizing the numbers on a dice and the numbers on a dominoes, and then they'll be recognizing the numbers written as a figure. And of course, we're surrounded by numbers, so be pointing out numbers to them on doors, on prices, on clocks, on birthday cards, on the end of the supermarket tills and the petrol station pumps. And then this is just a little guide on how we write the numbers. And it's really important that they get into good habits and that they start their pencil where these dots are, so that the strokes become second nature to them. So the manipulatives and pictorial models that we use, we use them because they expose this mathematical structure that is helpful to their understanding. So Mnemocon is a big one in reception and in year 1. And they get to recognize the numbers, but they also then use them for number bonds. So bonds to 10, finding the difference. They use them for odd and even numbers, and then for addition and subtraction. So here in year 1, they would learn to spot the odd one out, and they notice that the odd numbers have one little bit sticking out on its own. And then in year 2, they'd be using that to investigate the fact that an odd plus an odd is an even, because the 2 odd bits come together to make a pair, and an even plus an even is an even, and an even plus an odd is an odd. And they will also be using them for their bonds to 10, and actually matching the pieces of Mnemocon together, and they can see that all of those then would stack up together to make the same number 10. And once they've got used to that, then in year 2 they can say to themselves, well, I know 7 and 3 is 10, therefore I know 70 and 30 is 100. So the part-part-whole model is used right from the beginning in reception, and I know that Mrs. Hanson and Mrs. Corshaw have been very busy using this recently, because I've been listening to all the little bits that reception children have been sending into them. So they might start off using concrete things like dinosaurs, like toy cars, different counters, and they might even have hoops, and they're putting them in. So if the whole is 7, what could the 2 parts be? Well, they could be 3 and 4. I could put 1 in there and 6 in that one. I could put none in this one and all 7 in that one. As they get used to that and they get used to talking about it, they can then move on to the abstract numbers. And the part-part-whole model can get turned on its side. So we have to make sure that they're used to seeing it in lots of different orientations. And then they get to know that sometimes they have the 2 parts, but the whole is missing. So if you've got 2 parts, what is the whole? You might have the whole, but one of the parts is missing. How can we find that missing part? And so this lends itself to addition and subtraction families, and realizing that at a very young age, they begin to realize the connection between addition and subtraction. So we've got 6 add 4 is 10, and 4 add 6 equals 10. 10 take away 6 is 4, and 10 take away 4 equals 6. And we can get all of that from one part-part-whole picture. So in reception, they will be looking at walls of 5, or we can sometimes have just the 5 on their own. We call it a 5 frame, and particularly using different coloured counters. So they'll be saying, okay, I've got 5 red and no yellow. I've got 4 red and 1 yellow counter, and that makes 5. And then they begin to use different language. They're saying 4 red add 1 yellow equals 5. So the language is built up as they're looking at it. And then year 1, we very much use 10 frames. So they have the 10 frames sort of laminated. They're using double-sided counters. They're red on one side, yellow on the other, which is really useful for addition and subtraction. So they might start off very simply with 2 add 3. So I've got 2 red and 3 yellow. What have I got all together? And then we can use them as a picture. So this then might be a picture that they're looking at. So we've gone from the concrete to the pictorial, and they're very useful for team numbers. So they will begin to recognize that when a 10 frame is full, we know we've got 10, and then we don't have to count that 10 again. We know we've got 10, so we can say 11, 12, 13, 14. And so that's why they're really useful for the team numbers. And then, of course, they can start to draw their own. So they can have blank ones, which they can use their whiteboard pens with, and they can draw them in their books. Bar models are almost the same as a part-part-whole model, except we do tend to use them a lot in Key Stage 2. So we're introducing it early so that they got used to it, but it is basically the same idea where we've got the hole at the top and then the bar underneath is split into parts. It could be 2 parts, it could be 3 parts. And that relationship between the whole and the parts. So it can lend itself to problem solving. Do I need to add? Do I need to subtract to find the part that's missing? Bead strings, I've just noticed a bit of an error here. Bead strings are really useful in year 1 and year 2, again for team numbers, because we've got 10 red beads and then we can count on some more of our white beads so we can make the team numbers. They're useful for times table, for counting in steps of 3s, all sorts of things. And they link very closely then to drawing number lines. Number blocks is also used in reception and in year 1. The short programs had a lot of input from Debbie Morgan, who is the head of maths, primary maths at the NCETM. And so there is brilliant mathematical language in them, but also the way that they have been designed really helps children understand the concept, and is so much better than Numberjacks, which some people might remember if they've got older children. So mathematical language is key to everything that we do, and is sometimes the part that children find difficult. So there's a big emphasis on speaking and being confident with explaining and justifying their mathematical reasoning. So we really encourage the children to answer in full sentences, and the scaffolding means that we give them words and patterns of sentences to say. So even in reception, you hear them saying, 1 part is 3, 1 part is 4, the whole is 7, or combined, the whole is 7. And we question them with very open questions, so asking them, how do they know? Show me, prove to me, explain to me. In Key Stage 2, convince me, so that they are using the mathematical language to explain themselves. So the sorts of things that we might be saying in reception moving into year 1, altogether, more than, plus, add, total, and all the addition vocabulary. So this comes from our calculation policy and just shows some of the main concepts of addition at Key Stage 1, reception Key Stage 1, and then how we use apparatus, and then how we move to the pictorial and how we move to the abstract. So you can refer back to that. So sorry, we have got the combining two parts to make a whole, starting at the bigger number and counting on, and then regrouping to make 10. So we'll just look at those in a bit more detail. So we start off by counting all. So I've got 3, I've got 2, I'm going to push them together, I'm going to count them all, and altogether I've got 5, and that's how we start. And then very much in year 1, we are thinking, okay, now I don't want to do all that counting. I'm going to put the biggest number in my head. I know I've got 7 counters, and I'm going to count on from 7. So 8, 9, 10, 11, 12. So that's the next step. And then we can also do that on a number line. So the biggest number I have here is 6. I'm going to start on 6, and I'm going to count on 5 to get to 11. And then in year 2, we might be using 100 square, which is brilliant because we can go up, we count across in ones and we count down in tens. And in year 2, we do a lot of counting, starting from a number like 4 and counting in 10. So 4, 14, 24, 34. So they get used to counting in those steps of 10, which really helps them with their addition and subtraction. Then the subtraction vocabulary. So again, this is being slowly introduced from reception: subtract, fewer, minus, take from, take away, less than, and the difference between, which is the tricky one. And again, this is from our calculation policy. So we've got the 3 stages of the concrete, the pictorial, and the abstract. And we start with taking away ones. Then we've got this idea of counting back. So initially we are going to be having dinosaurs, jewels, whatever it is. We start with 4, we want to take away 2 of them. What have we got left? And then on a on a number line, we might start with 10 and we're learning to count back 5. So I think my monkey moves. There he goes. So we're counting back 5. And then with the 100 square, if we're starting on 34, we know we can take away 10. So we can actually move back up to 24, and then we can subtract the 2. That's the next step. With a tens frame, we would get all the counters that we're starting with. So we're starting with 16, and then we're removing 7 of them. And the good thing with the tens frames is that it helps us see that crossing over a 10. So I've got here, I've counted out 16, but it is actually a 10 and a 6. So I can take away 7 by taking away 6. I don't even need to count them. 6 have gone, and I'm taking away 1 more. So if a child can represent a number fact in several different ways, they really have a deep understanding. So we're encouraging the children to look at the same number facts in many different ways. So we've got our tens frames, our part whole, our bar models, and you can see the family of 2 addition facts and 2 subtraction facts for each. And this is really helping them grasp that understanding that subtraction is the inverse of addition. So moving into year 2, sorry, this is a little bit deformed, my 100 square hasn't come out quite right, but it's all about 2-digit numbers. So looking at the unit cubes, the 10 rods, and the 100 squares for base 10, and looking at what number is this. So we've got 1 10, and we've got 3 units, or 3 ones. We've made 13. It's got 1 10 and 3 units, and we do interchange. Tend to call them ones in year 1 and 2, but we do interchange that with units as they get older. So we have made 22. We've got 2 10s and 2 units. And then they can also represent this in their own drawing. So they might start to draw a 10 rod as a line, and the ones as little tiny squares or as spots even. So you can see here, and this is in year 2, on the green bits of paper there, they have been drawing their own numbers and then using the greater than and less than signs to compare the numbers. So year 2, there's a lot of partitioning. Partitioning just means splitting the number, splitting it into its tens and its ones. And then we use that partitioning to add. So there are 45 boys in a school and 36 girls. How many altogether? So the children will split each number into the tens and units. So I've got 40 and 5, 30 and 6. I put the tens together, so I've got 70, and then I put the 5 and 6 together, and I've got 11. And then the 70 plus a 10 plus a 1 is 81. And with all their work on in counting in tens and counting in ones, that begins to come naturally, hopefully. So we also use addition on a number line, where we're starting with the largest number. So we call it a blank number line because the children draw their own line. They put their 72 down. That is the big number that they have, and they need to count on 23. So they count on in jumps of 10, and then they count the 3 ones to get to 95. This is just another example. So here we've got 25 add 47, but they would be looking at this and saying, which number shall I start with? I'm going to start with 47 because it is the largest number. I don't want to have to count on any more than I have to. So now I'm going to count two tens in one go because I'm really good at counting in tens. I know that that is 67. Add 3 to get me to the next multiple of 10, 70, and then I can easily add on that extra 2 more. But I can only do this if I know that 5 is 3 and 2. So some children will be counting in 1, 68, 69, all the way along in 1 steps to start with. Okay, and so finally we get to land on 72. We know that those 2 numbers add to 72. And then subtraction using a blank number line. So we've got here 32 take away 18. We start with 32 and we're counting backwards. So we're taking away a 10, then we're taking away a 2 to get me to 20, and then we're taking away that extra 6 and we get back to 14. But we might start off with subtracting a 10 and actually counting in ones to start. So what number shall I start from on my number line? I count back in tens and then in ones. Are there any number bonds that can make this easier for me? So there we've used 2 and 6. We know that 8 is split into 2 and 6. Now here we've got a problem. So there are 54 children in a school and 38 are poorly. How many are left at school? So we might start by putting this into a bar model. I know the whole because the question says there are 54 children in a school, so the whole is the 54. One part of that whole is 38. 38 are poorly. What we've got to find is this other part. Now straight away they should be thinking, how do I find the other part from my part whole? I know, I subtract. So actually that's the calculation that I need to do. 54 take away 38. And then the other way that they can subtract is by partitioning only the second number. So they keep the 54 whole and they subtract 30 and then they subtract 8. So they jump back to 24 and then they do the 24 take away 8 to get to that. So finding the difference between 2 numbers can be tricky, because difference in normal language outside of maths means something completely different. So it is about getting used to the language. So finding the difference is common when we're finding change, because in the old days when we actually used money, shopkeepers would count the money into your hand, counting on how much taller is Ben than Jim, how much more money has Ben than Jim, how many more stickers does Ella have than Sarah? So all of these questions are thinking about the difference between what one person has and what the other one has in terms of quantity. So we've got here, maybe Ella's got 43 stickers and Sarah has 27. So we can find the difference by counting from the smaller number up to the larger number, because usually when we're finding the difference, the numbers are quite close together. And we can count on 10, we get to 37, count on 3, count on another 3, and we have got a difference of 16. And that is sometimes easier than a subtraction. So we use counting on a lot for difference. What do I add to 34 to get me to 57? So questions that children find really difficult at year 2 are these missing box questions. And this is where the bar model can help us. So I can think of it as, what I know my whole is 57. I've got 34. What do I need to add on to get me to 57? So we can use this counting on idea again. So 34 plus the 10 plus another 10 plus the 3, and we've got there. So I've added on 23. Or if we had thought of it as a bar model, I had the whole was 57. I knew one of the parts was 34. How would I find that other part? We might have decided to do 57 take away 34. So multiplication, the first sort of stage of multiplying is doubling. So looking at doubling numbers. Then we talk about counting in multiples, so counting in 2s, counting in 5s, counting in 10s. And then we look at it as repeated addition, and then we look at arrays. So we'll look at all of these in a little bit more detail. So we start off in year 1, we're looking at, spots on ladybirds, spots on butterflies, pairs of socks, counting in 2s, counting 2p's, counting 5p's, so that we get that idea of counting in 2s and 5s. And then we're looking at groups. So here we have got 3 lots of 5, or 3 groups of 5, or 3 sets of 5. So we're using all that language, and then we record it as 3 times 5 is 15. And then with the repeated addition, we can use a number line so that we see these jumps of 5. We've got 3 jumps of 5, leads us to 15. And then with arrays, an array is just simply a picture that we use for multiplication and for division. And the good thing about arrays is that we can see this family of facts. We can see that division is the inverse of multiplication. So here we've got 3 lots of 4. So we've got 3 lots of 4 going across, or we could say we've got 4 lots of 3. And from this array, they can have 2 multiplication facts, 3 times 4, or 4 times 3 is 12. So in year 2, they need to know their 2 times, their 5 times, and their 10 times table. And actually, some of the more able children will move on to counting in 3s and 4s, but the 2s, the 5s, and the 10s are the crucial ones. So here you can see that an array can be used for both. So from this one array, we have got 2 multiplication facts, 3 lots of 5, or 5 lots of 3, and then we've got the 2 division facts. 15 divided into groups of 5 gives me 3 groups, or 15 divided into groups of 3 gives me 5 groups. So with division, they will start off with the concept of sharing, and then they'll move on to the concept of division as grouping. So initially, they're going to be doing the 1 for you, 1 for you. So 4 monkeys equally between 2 cages. They'll move those. What is half of 4? So they're saying 1 for you, 1 for you, splitting it, sharing it. And here we've got 15 strawberries, and we've shared between the 3 boxes. How many do they get each? They get 5 each. And then once that is fairly solid, and we're beginning to use arrays and times tables, we can then move on to how many 5s are in 15. I can see that there are 3 lots of 5 in 15, and it becomes that bit more abstract. So how can you help a child in reception? So singing, saying any counting rhymes, you know, your 5 little men, flying saucer, 10 green bottles, all those ones that go up and down in numbers are all fabulous. Looking for numbers all around you. So front doors, looking at odd and even numbers in roads, looking at the numbers on number plates in cars. So, if you're in the car a lot, when Charlie was little, he seemed to spend most of his time in the car. So he used to shout out the speed signs. He used to shout 30, 40 as we were driving along, looking at the numbers at the petrol station, at the supermarket till, counting anything that you have, counting pasta, counting Lego bricks, getting them to set the table and counting out the forks and spoons and things, estimating amounts, using their fingers and guessing. Now I've put the next part year 1 and 2, but obviously all these games can be played in reception as well. But any card games, things like Uno, Top Trumps, we've got lots of information on, lots of number. A normal pack of cards can be used to make 2-digit numbers, to make pairs that add up to 10, to play games like Pontoon where you're trying to get to 21, playing dominoes, getting that recognition. Anything with the dice is great. Games like Snakes and Ladders. Snakes and Ladders is brilliant for counting on. So although you might find it very boring, if you land on number 5, for example, and then you roll a 4, do they know that you have to go, I've lost my cursor, you have to go 1, 2, 3, 4, or are they still counting that first one on the 5? So that's a really important one for children who are in year 1, make sure they're counting on. Then playing with money, making a shop, making their own bingo game, that could take you hours. So give them loads of tiny little bits of paper. They can write all the numbers between 1 and 100, and then they can make you some little boards with 6 numbers on for each person in the family, and you can play bingo and they can use all the felt tips in the house. So time is a really crucial concept that is difficult, and it is one. Basically, children who are good at time are children who have talked about time at home, because it does need practicing outside of school as well. So if you have a clock in the kitchen that is a digital clock, and you've got one somewhere else that is an analog clock, talk about the differences between them, but talk about how many days there are in a week, how many weeks until your birthday, the months of the year. Hopefully we will be going on holiday one day. Tell me when it's 2 o'clock, when the big hand has got to the 12. Talk about how long journeys are, that language of before, after, later, earlier. You can play on the iPad for 15 minutes. When will that time be up? What will the clock look like when your 15 minutes is up? And playing games like What's the Time, Mr. Wolf? Measures, again, we can do all sorts of things at home, talking about bigger, smaller, longer, shorter, taller, looking at heavier and lighter. Cooking is fantastic for weighing, for reading scales, for counting spoonfuls, for pouring, half empty, full. All that language and use of that language will really help it sink in. And then shapes around us. So we have the 2D flat shapes, and then we have the 3D shapes, the solid shapes. So it is important to use the right vocabulary for solid shapes. So a dice is a cube, it's not a square. A Coke can or a tin of beans is a cylinder, and a football is a sphere, not a sphere, that they like to say. So this is just a little something that someone showed me at the end of a long meeting once, which I think is really nice to remember. Chinese bamboo, when you plant it, nothing happens at the first year, nor in the second year, or the third year, or the fourth years. You don't even see a single green shoot. And yet in the 5th year, in a space of just 6 weeks, the bamboo will grow 9 feet high. The question is, did it grow 9 feet in 6 weeks or in 5 years? And sometimes with maths, their progress you think it's going to be steady, but actually they might have a bit of a leap. And sometimes things just start to click and you think, oh, where did that all happen? But actually all the little bits that we've been doing through each class are all helpful. So thank you very much for listening. If you have questions, please email them to the office and I will try and maybe put together some of the common questions and answers. So thank you very much for listening.